Hi, Lynn again. All right, now we're going to multiply and divide. We're doing multiplying and dividing rational expressions or fractions. So what I'm first going to do is review how you multiply and divide fractions. If you're multiplying fractions, you can just go straight across this times this and this times this. Now, if we were going to do this as multiplication, so if we did 12 over 5 times 3 over 10, we could multiply straight across and get 36 over 50, and then we would have to reduce this. So one of my tips is always reduce before you multiply. So I noticed that there's a 12 up here and a 10 down here, and I can make those numbers smaller by dividing them both by 2. So this would turn into a 5, and that would turn into a 6. And so then I can look at these and go, okay, nothing in the numerator can cancel with anything in the denominator. So then this would just turn into 18 over 25. All right, so now what do we do different when it's division? In case you don't remember, division means you multiply by the reciprocal, which means you're going to flip over the 10 over 3. So this would turn into 12 over 5 times 10 over 3. And I'm going to parallel it to this. What you want to do then is factor these. So 12 is going to be 3 times 4. The 5 is prime, so it can't factor. And this is going to be 2 times 5 divided by 3. So any of the common factors in the numerator and denominator, because everything is multiplied, there's no pluses and minuses here, we can cancel them. So this 5 can cancel with that 5, and that 3 can cancel with that 3. So we're just left with 8 as our answer. So now we're going to transfer this into polynomials. So first of all, you're going to notice that there's a division sign. So we are going to flip over the second term. So it's going to be x minus 3 divided by, and just right now I see that this is kind of in the wrong order. So I'm going to do that trick where I factor out a negative 1 and turn it into x minus 2. And then I'm going to multiply. And another trick I have is when you have a factor, put it in parentheses. Then you know it's a group, and then it's going to multiply. So this is going to be in the numerator. And so that's x squared plus 2x minus 8. And the denominator is the numerator, so it's x squared plus 3x minus 18. Now these are factors. What's really tempting for a lot of people to do is to try to cancel, say, the x squareds. They cannot be factored because they are terms within a factor. So what we need to do is factor each one of these, and then like this, we will then get to cancel out the common factors. So I'm going to rewrite this, x minus 3, and then carry down that negative 1, x minus 2, putting that in parentheses. Now how do we factor that? That's going to be regular x factoring. That's going to be x and x. What multiplies a negative 8 and adds to 2? And that would be plus 4 minus 2. And the denominator, what multiplies a negative 18 and adds to 3? So that would be x plus 6x minus 3. So now everything is factored. So we are going to look for the common factors and come in with our pen and cancel out the common factors. So I notice that there's an x minus 2 here that can cancel with this factor, and the x minus 3 here that can cancel with this factor. Make sure that we remember that negative 1. So our final answer will be just what's left here, which will be, and I hope you can see this, x plus 4 divided by the opposite of x plus 6. And that would be your final answer. So there were all sorts of tricks in here. Remember to factor out the negative 1 here. We want to flip this over. We want to factor. If we're looking for what the domain is, we'd look for everything that ever could be in the denominator. So for instance, x could not equal 2 for the domain. And this is it. And x can't equal anything that's ever in the denominator, so it can't equal anything, since this flips over. This is in the denominator here, but then this is in the denominator here. So they both count as possible domain. So x cannot equal 2, can't equal -4, can't equal -6, can't equal 3. And so there's 4 things that x cannot equal, or else a denominator somewhere in the problem would equal 0. So those are my tips and tricks for multiplying and dividing rational expressions.